1,500 light-years away, in the constellation Cygnus, there is a star that keeps going dark. Not the slow fade of old age. Not the gentle, clockwork flicker a planet makes when it slides across a star's face. Something out there swallows up to a fifth of this star's light. Almost a quarter of it. Gone. At random, with no rhythm anyone has ever been able to find. And then, just as suddenly, it shines again. For a few weeks in the autumn of 2015, some of the most careful scientists alive said out loud the one thing astronomers are trained never to say. They looked at the data, and they asked each other, what if this wasn't natural? What if we were staring at the shadow of something built, a machine the size of a solar system, thrown up by a civilization we cannot imagine? This is the true story of the star cataloged as KIC 846-2852. The internet called it the alien-megastructure star. The mystery is completely real. The aliens were a genuine, published hypothesis. And the answer, when it finally arrived, turned out to be stranger than the question that started it all. To understand why this star broke so many minds, you first have to understand what a normal star is supposed to do. Between 2009 and 2013, NASA's Kepler-Space-Telescope stared, without blinking, at a single patch of sky, more than 150,000 stars at once. It was hunting for planets. The method was simple and beautiful. When a planet passes in front of its star, it blocks a sliver of light. The star dims by a tiny, precise amount, for an Earth-sized world, less than 1/100%, then brightens again, and does it on a perfect schedule, every orbit, like a heartbeat. Kepler watched for those heartbeats. The data was an ocean. Billions of brightness measurements, far too many for any team of scientists to read by eye. So some of it was handed to the public, through a project called Planet Hunters. Ordinary volunteers, scanning real starlight on their home computers, looking for dips a machine might have missed. And in that flood of ordinary stars, the volunteers found one that was wrong. KIC 846-2852 didn't have the neat, shallow, repeating notch of a planet. It had craters. Enormous, jagged, ragged plunges in brightness, some of them more than 20% deep, lasting anywhere from a few days to nearly 3 months, appearing, vanishing, and never repeating the same way twice. The volunteers flagged it. The case reached a young Yale astronomer named Tabitha Boyajian. She pulled the full light curve, and what she saw didn't make sense for any star she knew. A planet blocks 1%. Even a giant planet, a Jupiter, blocks barely more than 1%. This star was losing a fifth of its light to something, and there was no pattern at all. In 2015, her team published the discovery. The paper carried a subtitle that was half a joke and half a confession of how baffled they were. Where's the flux? Among themselves, they started calling it the WTF star. To everyone else it became Tabby's star, after Tabitha herself. So the investigation began, the way every good investigation begins, by trying to make the mystery boring. By finding the dull, obvious answer that makes the strangeness go away. The first suspect was the most obvious one of all, the telescope itself. Maybe Kepler had glitched. A smudge on a sensor, a flaw in the software, a processing error. That would explain a strange signal far more easily than anything in space. The team went back and checked, hard. They ruled it out. The dips were real. The light was genuinely leaving the star and not reaching us. Whatever this was, it was happening out there, 1,500 light-years away, not in the machine. So the second suspect stepped forward, and it was a good one, a young star. Newborn stars are messy. They're wrapped in thick disks of gas and dust, leftover rubble from their own formation, and that material can blot out starlight in big, irregular gulps. If KIC 846-2852 was young, the mystery was basically solved. But the star refused to cooperate. Its spectrum, the fingerprint written into its light, told a clear story. This was a mature, ordinary main-sequence star, a little bigger and hotter than our sun. No youthful chaos. And crucially, no glow of warm dust in the infrared, the telltale heat signature a dusty young disk would leave behind. The young star idea collapsed. Now the team needed something that could block a fifth of a grown star's light without leaving that infrared fingerprint. And here they landed on their own best guess, the explanation they published as the least bad option available, a swarm of comets. Picture a family of comets, recently shattered, perhaps yanked apart by the gravity of a passing star. A vast, ragged cloud of icy fragments strung out along an orbit, drifting across the face of the star, dimming it unevenly as the clumps pass. It almost worked. It was the leading idea for over a year. But almost is where this story lives. Even the people proposing the comets called the scenario contrived. You needed an extraordinary number of them, swarming in exactly the right way to block that much light. And the shapes of some dips, a slow, smooth dimming followed by a sharp recovery, were awkward for a simple comet cloud. The comets were a patch over the hole, not a fix. And then the mystery did something investigations are not supposed to do. It got bigger. An astronomer named Bradley Schaefer decided to ask a different question entirely. Not why is it dimming now, but has it always been like this? He went to Harvard, to one of the strangest archives in all of science, a library of glass photographic plates, over 500,000 images of the night sky, going back to the 1890s. A century of starlight, frozen on glass. He found Tabby's star on plate after plate, decade after decade, and measured how bright it had been. What he reported was almost as shocking as the dips themselves. Across roughly 100 years, from 1890 to 1989, the star appeared to have faded by around 20%. A slow, steady, century-long dimming. No normal star of this type does that. Comets cross in days. They cannot make a star quietly darken for 100 years. This was immediately, fiercely contested. Another researcher, Michael Hipk, argued that you cannot trust a century of photographs taken on changing equipment with changing methods, that the slow fade was an illusion baked into the archive, not a real event in the sky. The fight over those glass plates is, in some ways, still unsettled today. But then a second team, Benjamin Montet and Joshua Simon, found a way to test it that didn't rely on old photographs at all. They went back into Kepler's own data, into calibration images most people ignore, and tracked the star's brightness across the 4 years of the mission with extraordinary precision. The star was fading there too. For most of the mission, it dimmed slowly, then dropped sharply, losing several percent of its light in under a year. And out of hundreds of similar stars they checked in the same way, not one other star did this. Tabby's star wasn't just dipping. It was disappearing on more than one timescale at once, and it was alone. Now stack it all up the way the scientists had to. Deep, random, enormous dips. No infrared heat. No youth. A possible century-long fade. A sharp drop inside 4 years. One star, unique among hundreds of thousands. Every natural explanation had blocked one window and left another wide open. And into that gap walked the strangest idea of all. An astronomer at Penn State named Jason Wright did something brave and careful. He pointed out that there was a hypothesis no one wanted to say first, and that, precisely because it was so extraordinary, it deserved to be tested rather than ignored. What if the thing blocking the light was built? The concept is decades old. A physicist named Freeman Dyson once imagined that a sufficiently advanced civilization, hungry for energy, might disassemble its own planets and build a vast swarm of structures around its star, panels and collectors capturing its light. Not a solid shell, but a cloud of machines. A dyson-swarm. From far away, a half-finished swarm like that would block starlight in big, irregular, unplanet-like gulps. Wright, together with Stein Sigurdsson, laid this out as a real, falsifiable hypothesis, something you could test and disprove, which is what makes it science rather than fantasy. They were explicit that it was a long shot, an idea of last resort. But it fit the one fact nothing else could touch, that this star was doing something no other star would. And so, for the first time in a generation, telescopes built to listen for alien civilizations swung toward a single point of light. In October of 2015, the SETI Institute aimed the Allen Telescope Array, a field of radio dishes in California, at KIC 846-2852, listening for any deliberate radio signal leaking from the system. They listened. The Breakthrough Listen project searched, too, for radio and even for laser pulses, the kind of optical signal a civilization might use to talk across the stars. The silence was total. No transmissions. No beacons. Nothing artificial in the noise. There was another test, quieter but just as damning. Any real machine harvesting a star's energy has to dump waste heat. It would glow in the infrared. NASA's infrared telescopes looked. They found no excess heat. A working megastructure should have left a thermal signature, and the star was cold where it should have been warm. But none of that closed the case. Absence of a radio signal isn't proof of absence of aliens. Maybe they simply weren't broadcasting at us. The megastructure idea was wounded, not killed. To truly settle it, scientists needed something they'd never had, to catch the star in the act of dimming, live, and read the color of the light it lost. Here the story turns on one of the most remarkable things in modern astronomy. Voyager didn't wait for a grant. She launched a Kickstarter, and more than 1,700 ordinary people, the same kind of public that had spotted the star in the first place, pledged over $100,000 to buy telescope time. From March 2016 to December 2017, a global robotic network, the Las Cumbres Observatory, kept the star under near-constant watch, dozens of telescopes around the planet handing off the vigil as the Earth turned. They were waiting for it to drop. And in May of 2017, it finally did. The star began to fade in real time. Telescopes everywhere locked on. Over the following months it produced 4 distinct dips, and the team gave them names: Elsie, Celeste, Scarabray, Anchor. For the first time, scientists were watching the mystery happen as it happened, measuring the lost light not just in quantity, but in color. And that was the whole game. Because a solid object, a planet, a star, a slab of alien metal, is opaque. It blocks every color of light equally. Block the star with a wall, and red, blue, and everything between dims by the same amount. That is simply how solid things cast shadows. But that is not what they saw. The star dimmed more in blue light than in red. The shadow had a color. And a colored shadow cannot be cast by anything solid. It can only be made by something fine. Tiny particles, smaller than 1,000th of a millimeter, scattering some wavelengths more than others. The blocker was dust. Not a comet wall, not a planet, and not a machine. A vast, fine cloud of microscopic dust drifting around the star. In 2018, Voyager's crowd-funded team published the verdict, and NASA put it plainly. The most likely cause of the strangest dimming in the galaxy was an uneven ring of dust. The megastructure was ruled out. By light it should have hidden, and didn't. So that's the answer. Except it isn't. Not really. And this is the honest, unresolved heart of it. Knowing the blocker is dust only sharpens the real question. Where did the dust come from? Dust this fine, this close to a hot star, shouldn't last long. It should be blown away. To see it now means something made it recently, and made an enormous amount of it. Scientists have ideas. A planet or a moon shattered in a recent collision. In 2019, one team proposed an orphaned exomoon, a moon torn from its world and slowly ground to dust as the star boiled it away. These are real, serious hypotheses. None of them has been confirmed. And the deepest puzzle of all is still standing. Even with the dust, no single explanation accounts for everything at once. The deep dips, the possible century-long fade, the sharp drop inside the Kepler years, and above all the simple, stubborn fact that out of every star we have ever watched this closely, this one alone behaves this way. What we know for certain is that the dimming is real, that the blocker is fine dust, and that it is not an alien megastructure. What remains a working hypothesis is where that dust was born. And what stays pure, open speculation is why this star, and only this star, became the strangest light in the sky. The aliens were never the answer. But they were never a foolish question, either. Real scientists raised that possibility in print, then did the harder thing. They built the tests that could prove themselves wrong, listened to the silence, read the color of a shadow, and followed the evidence to dust. That is what makes this a true story and not a myth. Somewhere in Cygnus, a perfectly ordinary star is still wrapped in a cloud no one can fully explain, still dimming on a schedule of its own. We solved what it isn't. We have not yet solved what it is. We're still watching it, and we'll keep watching. Subscribe, and keep your eyes on the dark.